Hi guys, this video is going to be on learning targets 7 and 8. We are going to explain operations on irrational and rational numbers and learn what those are. And we're also going to solve equations using square roots. Let's begin just by defining what the square of a number and a square root of a number are. So you guys are familiar with 2 squared is 4, 3 squared is 9, 4 squared is 16. You know how to square a number. A number is just the product, or a square of a number is just the product or the multiplication of a number and itself. So for example here, x squared would be written as x with the exponent of 2, or that's going to be x times x. In the same way, 3 squared is 3 with an exponent of 2, which is also equivalent to writing 3 times 3. Exponents help us write things that could be written out in expanded form more cumbersomely in a more simplified version. The square root of a number is just the opposite of that squaring. Every positive number has 2 square roots. This might be new to you, that every positive number has 2 square roots. So for example here, the square root of 36, we know that 6 times 6 equals 36. So that would be 6 squared is 36. But also, if you think about it, negative 6 times itself, so negative 6 times negative 6, a negative times a negative is a positive. So that's going to be a positive 36. So there's also the opportunity for negative 6 squared to be 36. So every positive square root will have 2 answers for that. All right? In the same way, you cannot take the square root of a negative number. This does not exist. Okay? Because no number times itself will equal a negative. So we can use square roots and squares to find answers to equations. We're going to use just some squares here to find some answers for, if we have this square here and we know its area is 81 inches squared, we want to find the side length. So let's label the side length x, and we know that all 4 sides are going to be x because by definition a square has 4 equal sides. So all of these x's are going to be the same. So we need an x who, when squared, equals 81. All right. So we've talked about the fact that square rooting is the opposite of squaring. So if we square root here, both sides, then the square root of x squared, the square root and the squared are going to cancel, and we're just left with x. And then over here, we have the square root of 81, which we all know that 9 is the square root of 81, but what we just learned is that also negative 9 is the square root of 81. Now when we're talking about an actual square here and its side length, we know that this length is probably going to be a positive number 9 inches. Okay, but also the square root of 81 could be a negative 9. So our answer mathematically would be positive or negative 9, but in the common sense real world way, our answer is going to be that positive 9 inches. Okay? We could also just write that as the square root of 81. This is a number. It is not, however, simplified. Positive or negative 9 is the simplified version of that. We'll see a square root here that cannot be simplified as we go on to this green square here with an area of 5. So if I label our sides n now, we need an n who squared is going to equal 5, because we know n times n will give us the area. The side times itself gives us the area, and I guess I didn't mention that up here. We know that x times x will give us the inside of this square by definition of area. So we have an n times n, which is going to equal 5. So again, to undo our squared, we're going to take the square root of both sides, and n is going to equal the square root of 5. Now, we don't know the square root of 5. We don't know exactly what that is. And so we actually are going to leave this answer like this. Okay, the square root of 5 inches. We can go ahead and label that as we would. We know it's going to be a positive or negative number somewhere between what two numbers do you think? Well, we know that 1 squared, 1 times 1 equals 1. 2 squared, 2 times 2 equals 4. And 3 squared, 3 times 3 equals 9. So we know it's going to be in between 4 and 9 because, or we know 5 is in between 4 and 9. So we know our answer is going to be in between 2 and 3, probably closer to 2 because 5 is closer to 4. All right, but we don't actually estimate those unless we're asked to. This is going to be our answer for now. That's the most exact answer you can give. So what we just looked at there was an example of irrational and rational numbers. In the examples we gave before, the square root of 5 was an irrational number, and the square root of 81 was a rational number, and we're going to look at why that is a little bit here. An irrational number, if you haven't heard before, is a number that cannot be expressed as a ratio of two integers. In other words, it can't be written as a fraction. In decimal form, this number has an infinite number of digits. Okay, the digits behind the decimal will go on forever, and they do not repeat. So they're not just 2.181818 or 3.9 repeating. They will not they will go on forever. A rational number is one that can be written as a ratio. So we knew that the square root of 81, one of the answers there would be 9. 9 can be written as 9 over 1, right? And so we can write that as a fraction. Rational numbers include those that can be written as a fraction, include integers, which are the positive and negative counting numbers, whole numbers, which are your positive numbers plus 0, and then natural numbers, which are basically just your positive counting numbers. Okay, and we have a little chart here that shows our irrational numbers. Probably the most popular irrational number is pi. You guys have seen that number before, that decimal with the posters on the wall that have just almost thousands of numbers or numbers behind that decimal, and those numbers actually go on forever. Square root of 7 is another number, kind of like the square root of 5, that you don't know a whole number answer to, so that's going to be a decimal that repeats forever. Also, this 3 plus the square root of 5 is also going to be irrational because that's 3 plus that irrational number 5, so that decimal is also going to be going on forever. The whole number in front of it is just going to be 3 larger. Within the rational numbers here, you can see those that are written as fractions, the negative and positive integers, the whole numbers, and the natural numbers there in the center. For class, your assignment is to just add another number to each category in the chart above. So what's another irrational number, another rational, another integer, another whole, or another natural? You can't think of another whole. Actually, you can put another whole in there, so one that would fit in there, but it would probably also fit in the naturals. Okay, and we will talk more about any of your questions in class.